Hi there, and welcome to this lesson. In this lesson, we'll be learning longitudes and latitudes. Okay, so on the longitudes and latitudes, we'll be learning about great and small circles. Now, as the lesson progresses, anything you don't understand, be sure to get across to your tutor, who would be more than happy to help. And yes, let's jump right into the lesson. So, longitudes and latitudes, great and small circles. Now, great circles. What are great circles? Now, a great circle is a circle that cuts through the center of the earth and divides the earth into two equal halves. Okay, so the great circle, your great circles are your equator. Okay, so your equator is a great circle. All the longitudes are great circles. If you think about the longitudes, basically, if you think about an orange, the longitudes pretty much divide the earth into two equal parts, but they do so at different angles. Okay, but then they are all great circles. Okay, so basically they cut through the center of the circle and they are pretty much the same circumference as the equator. All right, now if you're looking to find the circumference of a great circle, basically you have the radius of the earth. The radius of the earth is 6,400 kilometers. Okay, if you're looking to find the circumference of any great circle, you just multiply 2 pi times 6,400 and you get the circumference of a great circle. Simple. Now, where it gets interesting, small circles. Now, small circles, on the other hand, like we learned, do not divide the earth into two equal parts. Okay, they do not cut through the center. And when you're thinking small circles, you're thinking about your latitudes. Okay, and if you look at your latitudes, basically if you look closely, the latitudes are different at different angles. We have different sizes of circles. Definitely do not divide the earth into two equal parts. And how exactly do we find the circumference of a small circle? Now, the circumference of a small circle, like you would see on the diagram there, it depends on the latitude where you have the small circle. Okay, so here's our earth. All right, we're looking to find the circumference of a given small circle. So here's our earth, here's a line dividing our earth, and here is our equator. Okay, now following our equator is a small circle. Okay, and this small circle is somewhere, so particular angle, latitude, somewhere in the northern hemisphere. Now we have the radius of our earth at our equator here. Okay, and then we have the radius of this small circle. Okay, now clearly there are different sizes, so you have two different radii there. So you have the radius, the big radius, which is 6,400 kilometers, and you have a radius of this small circle. Now we're looking to find the radius of this small circle. Now this small circle, we have it at a latitude theta degrees north. Okay, and then what that means is a line drawn from the center right from the equator would have an angle theta degrees, basically. Now, a line drawn from the center of the circle up onto any point on the surface of the earth is the radius of the earth. Okay, is the radius at the equator. If you think about it, okay, when you have a sphere, if you join any line, if you draw a line from the center of the sphere to any point on the surface, you actually have the radius of the radius of the sphere, i.e. the radius of the great circle, the radius of the equator. Now in this case you have r there. Okay, you have theta would also be there. Basically we have alternate angles there. And what you would see if you look closely, you have small r, theta, and big R forming a right angle triangle there. Okay, and basically the small r will be the adjacent, big R the hypotenuse. And what that is that small r over big R would give you cos of theta. Now typically if you're looking to find the radius of a small circle at a given latitude, you pretty much just have to find r cos the latitude angle. Okay, and basically if you're looking to find the circumference after finding the radius at that of the small circle, you go 2 pi small r, and that would give you the circumference of a latitude. And that's it. Okay, so let's go ahead and solve some examples. I have example 1. Find the radius and circumference of the small circle at latitude 38 degrees south. Okay, and we've been asked to take r as 6,400 kilometers. Now We have that r equals big R cos theta. Big R is 6,400 kilometers, theta is 38 degrees, and r is 6,400 times cos 38. That gives us 606,112 kilometers. Now we have to find the circumference, we pretty much just go 2 pi r. We have 2 times pi times 6,112, and we end up with 38,403 kilometers. And that's it. That's pretty much all you need to learn as regards small and great circles. Okay, we will do more of this when we start solving for distances along longitudes and latitudes. But yeah, you can go ahead and attempt questions on the worksheet. Bye for now.